I know you can see it on here, I don't really care. I want you to use your calculator and find the maximum. This is the maximum, right? The highest you can go is like a mountain. So find the maximum. How do we calculate stuff? Second, what do we put? Second what? Rhymes with face. Oh my gosh, you know what to find this. Thank you. Because above traces, calc, because we're calculating something, right? And we're calculating what today? Maximum. Hmm?
It doesn't show the little dot.
Yeah, I can't see the dot where it's going.
Yeah.
Okay, so fun fact. I only learned this way too late in my life. If you look at the bottom of your screen, it tells you where the little dot is. So where's yours say?
Oh, never mind, I got it.
So it's either way above or way below,
It would
right?
move. Like I press down and it just stay at 19.
Left to right.
And then I go left to right and I can't see it still.
We're going for maximum?
Follow your.
It was at Y19. I don't know. It's really weird.
So you're at 0.2 and negative 16, so go left. Or sorry, right. You want to make sure.
I don't know what the dot is.
I was like super far
Your dot is at negative 3 and negative 83.
I was at
So it's
positive
like
19
negative
and I'm like
3,
negative 60.
negative 83. It's down
What?
here. Trying to put it back up. Yeah, like this is your screen. It's like here on the screen.
How do I get it back up?
How do you move it? No, it's left or right. So now you're at negative 1, 5, negative 18. Oh, there she is. Oh, there it is.
Yeah, that's what I was thinking. Happy birthday.
Yeah, that's right. That goes to 6.
Right now. Yeah. Oh, there we go.
There we go.
That's sad. That was a little. Even I didn't see. Yeah, I didn't mean to.
Are you going to take Okay, everyone get it? Did you get it, Sansel? You got it?
I'm still trying to door off your car.
So guys, what are you getting? Yes, what did you get? 3 and negative 1. And it shows it on here. Okay, so we agree, we go up here. Our, actually it's down, it's down here. So down here is where we're going to put it. So the vertex is at 3 and negative 1. And aggressively tick mark. Okay. Now, the equation was this. It was y equals negative 2x minus 3 squared minus 1. We agree? That's what your equation was. Yes?
Yeah.
Okay. Now, I told you that if there's a negative in front, we're going back to yesterday. If there's a negative in front, what does it do? Makes it open down. So this graph's down. We agree? What does the 2 in front do? It makes it narrower than just your basic x squared graph.
I'm really good at slopes if you need.
We need parabolas, so. Grade 10. Fine, Jill. Okay, so. Yeah, rock slope. Yeah. In mine, sleep. I can slope. Not ski slope, but like math slope. Yeah. All right. So we know that it is more narrow than the x squared and it's concave down because of the negative. We agree? Yesterday, what did this tell me? You moved what? Remember? Left or right? If it was x minus 3, we actually moved right. How many? 3. We moved right 3. Oh, look at that. It moved us right 3. It moved us right 3. Do you see the x of the vertex? It's actually the same as the x of the vertex. If you figure out which way you're moving, right or left. Okay? And what did this one do? The cube. It moved it up or down, and in this case, which way? Down 1. Remember the Q is the same, and the P was if it's negative, you actually are moving right, and if it's positive, you're moving left because of that negative sign that's in the equation. Okay? So this matches the y is the vertex. That's called vertex form. This here, this y equals a x minus p squared plus q. That's vertex form. Why? Because it gives you the vertex, aka vertex form. Isn't it crazy? Good word. So it's vertex form because it gives you the vertex. So the vertex of this form, this would be p, q. That would be the vertex. Because we take this opposite of this, same as this, because this is going p to the right, this is going q up. So pq. Remember, because there's that minus sign, the p is always the opposite direction. But the q is always the same. Okay, what's the axis of symmetry? X equals, we know that. X equals what? 3. Because the axis of symmetry, we're going to remind ourselves again, is the x of the vertex. It's the line that cuts the graph in half, right? So in this case, it would be this line, which is x equals 3. Now, is a greater than 0 or a less than 0 on that equation? Your a. Is it greater than 0 or less than 0? It's less than 0. And what does that tell me? Concave down. And if it's concave down, does it have a max or a min? It has a max. So that's also what it tells me. What's my domain? It's bulking up. What's my domain? X such that x is a element of the real numbers, because my head is this maximum, and then my arms zoom up for this, and then zoom up for this, and then boom, it goes on forever, right? So remember I told you that quadratics go out forever. This way or this way. They go out forever. So the domain of every quadratic, unless it's a word problem, is XCR. We're going to discuss interval notation later. We're just going to do set notation for now. Now the range, this baby's downwards, right? So what's the highest y I go to? -1 or down. What does that mean in an inequality sign? Less than or equal to, because it's a closed dot. Thank you. That was very quick. Y is such that y is less than or equal to -1, YER. Okay? You agree? Okay, let's look at the other one. So we are going to go, type that in, 2x plus 1 squared minus 2. Ooh. I want you to type it in, even though the graph is drawn for you, I don't really care. You need to type it into your calculator, and this time we're going to find the vertex by calculating the what this time? The minimum. So we're going to do second trace minimum, number 3. So everyone try and find your vertex, please. So we found the minimum. It's at -1 and -2. Now, I don't actually need the graphing calculator, and I don't need the graph. And I don't need your phones, so make sure your phones are away. Okay. So I don't need the graph, and I didn't actually need my calculator, because your vertex, when it's in vertex form, can just be pulled from the equation, correct? If this is a +1, which way did I move? 1 to the left, which is actually what number? -1. And then this one I moved 2 down, so it's at -2. So I can pull my vertex right from there, correct? Opposite of P, same, same P. Opposite of this sign, same as this sign is my vertex. So if it's in vertex form, I don't even need my calculator. I didn't need a graph. I can just take the opposite of this, same as this, right? Now my axis of symmetry is the x of the vertex. So it's x equals what? -1. And we know we're right because This is actually x equals -1 on the graph. We scroll up a little bit. See? That's the equation of my axis of symmetry. It's the line that would cut the graph in half, the line that if you folded it, you'd have the same on one side as on the other. Is your A greater than 0 or less? Is your A greater than 0 or less? It's greater because it's positive, which means it's concave up and a what? Max or min? Min. Because it's like a valley. What's the domain if it's concave up? It's doing this or it's doing this. What's my domain? X such that x is an element of the reals. So the set of, that's what this squiggly bracket means, x values, because the domain is x values, such that straight up and down line, x is an element of the reals. What's my range? What's my lowest y? -2 or up, which is greater or less? Greater. So it's going to be y such that y is greater than or equal to -2 y e r.
So how we go for the domain, is that only for when it's like this?
A quadratic, yes.
Only that?
Yeah. Because we're going to have to always check once we get to, so in grade 11, a lot of the functions we look at for graphs-wise are only quadratics. But then when we hit grade 12, we do quadratics, we do linear quadratics, cubic, quintics, quartics, we do radicals, rationals, we do trig graphs, we do logs and exponential graphs. So it will, your domain and range, you have to be able to look at the graph and figure out what's not there, and then write what is there. Okay, 'cause it's going to change. Yeah, but you're right. For quadratics, because we're going out like this or like this, the XER. But linear is in grade 10 as well. We're XER because a linear graph does this, right? So it's going to go out for life to the left, and it's going to go out for life to the right. And if I can say all the x's exist, there's no place where the x's don't exist, it's XER. So this would be XER as well, too. Yeah. Sure. Okay, we're going to go to the next page. All right, we're not going to deal with the transformation part of this. Okay? We're going to do the first one together. We're going to leave the transformation part out for now. We're just going to do this first part. Okay? We're going to do the vertex, axis, symmetry, domain, and range. And I don't even want you to type it in your calculator. You're not going to touch your calculator because you're not going to need it. Okay? Because what form are we in? We're in vertex form. And what will the vertex give us? Vertex form give us? Give the answer. It'll give us the vertex, which also gives us the axis of symmetry, which also will give us the domain and range. So let's try it out without our calculator. So I always do a quick sketch first. Is this baby concave up or concave down? It's concave up. We agree? So it's going to have a minimum, and my range is going to be greater than or equal to. We agree? Whenever you have a min. So if you do a sketch really quick, you'll know if your range is greater than or equal to or less than. If the arrows are up, it's greater than or equal to. If the arrows are down, it's less than or equal to, right? It helps you with a quick sketch with your range and your domain. Okay, what's the vertex of this equation? What's my x going to be? Yeah, if it's x minus 1, it's actually going to be plus 1. And this one's a plus 1, so it's going to be plus 1. So we always do opposite of this, same as this. Okay? Opposite of the x, same as the y, and that's because this is x minus and this is my actual p. What's beside the minus sign? What's my axis of symmetry? X equals 1. It's just the x of the vertex, the x of the vertex. So I'm going to write this up here to help myself out. X of vertex. So x equals 1. What's my domain? It's crazy Jesus are bulking up. What's it going to be? Up, and so it's going to be x and down with the reals, x and down with the reals. Doesn't really matter, right? So my domain, I'm going to put a d by it. It's going to be x such that x and down with the reals. My range, remember, I can do this beside it if it helps me. It's going to be concave up. And is the range based on the x or the y? y's. And what's my y? X and y are both actually 1, but my y is 1. We agree? So this here, the lowest this goes, is y equals 1. We agree? So if I look for the y of the vertex, it gets me the value I need on my range. Right? Because the vertex is at 1, 1. Well, the lowest this goes to is 1 or higher. So I'm going to go y such that y is greater than or equal to 1, y-er. You're going to try this one, the second one. Try this one out. What's my vertex at this time? Opposite of this, so what's that? Nikki? What's it going to be? Opposite of this? -1, same as this? 3. Exactly. So when it's in vertex form, boom, we have the vertex. Could you type it in your calculator and find it? Sure. No problem with that. Okay, the equation of the axis of symmetry is x equals what, Chloe? -1. The x of the vertex. Now, is this graph concave up or concave down? Concave. I just said concave. Yes, concave up. No, I said concave. You said it correctly. It was me. I completely omitted the C part of it. So, it's concave up. What's the lowest it can go to? What's my lowest y? Y equals 3. Right? So I will always write beside it y equals 3 so that it pulls me to the 3 and not the -1, because people will just get the wrong range. Who does that?
Yeah.
Silly people. Okay, so the domain is still x such that x and L are the reals, because it's a quadratic and not a word problem. And my range is going to be y such that y is greater than or equal to, because the arrows are up, and then 3, because that's the y of my vertex, y-er. Okay? Okay. You're going to try these. What happens if I have this? Before we try these. What happens if I have this? What's with my x? Technically nothing, correct? So I can write this as y equals -2x plus what could I add to it? What could I add that would not change it? What would be there if I didn't have anything? X plus what represents nothing in the world of mathematics? 0. So when there's nothing with the x, rewrite it like this. So my vertex would technically be -0, but would I write -0? No. I'm going to write 0 and -1, right? What about this one? So those are the ones where I don't have with the x. What about this one where I don't have anything at the back? What would I have? A plus? What can I add that's not going to change this? +0. So my vertex for this one would be at 5, 0. Right? So if the x doesn't have anything with it, put a +0. If the back doesn't have a q, put a +0. Okay? So try these. This one I would rewrite as -3x plus 0 squared plus 4, because there's nothing with the x. Okay? Try these out. So we have x minus 3 squared plus 2. What's my vertex at? You can just say it out loud. 3 and 2. Okay. Xander, what's my vertex going to be at? Or not my vertex, sorry, my axis of symmetry. X equals 3. And what's my domain and range going to be? The XER1, yeah. Y such that y is, it's concave up. That greater than or equal to, no, what's my y? 2. Got it. Y, E, R. Okay. Chloe, you're helping me with this one. What's my vertex at?
-5,
-5 and -3. That's my axis of symmetry at.
X is
equals -5. My domain.
X minus 4.
And then is it concave up or concave down?
Yeah. I'm sorry, wrong one.
Yeah.
Concave up.
It's up because there's +1 in front. Yeah. So my range is y such that. Yeah, -3 y-er. Leon, you're my next victim of the math. Okay, is this one concave up or concave down? It's down because of the -2. What's my vertex at? You got it. What's my axis of symmetry at? X equals 0. My domain? X such that X is number of the reals. My range? Yeah. So it is concave down, so y is less than or equal to -1. You got it. Perfecto. Okay. Now I'm going to bug James. What's my vertex? This one? Sorry, not this one. This one. The one above. 0 and 4. Exactly. What's my axis of symmetry? X equals
0.
0. Is it concave up or down?
Down.
Down because of the -3. My domain? X such that?
X.
Yep. And my range? Y such that y is less than or equal to
0.
the y. What's my y on that one? You're looking at the one below it. What's my y on this one?
4.
4. Y here. All right, Gabby, you're up next. So, is this concave up or concave down? Down because of the negative. What's my vertex at?
5 and 0.
5 and 0, opposite of that, same as that. X equals, from axis of symmetry, 5. What's my domain?
X is X to be our
Yeah. And what's my range?
Y less than 0 y yard.
Less than or equal to 0 y here. You got it. Hey, Hannah, you're up next. Concave up, concave down. Because of the -2. What's my vertex at? 6, 0. What's my axis of symmetry? X equals 6. What's my domain? Exactly. And then my range? You got it. Okay. I don't remember what I signed yesterday. Which one of these did I sign? I know I signed some of them.
No.
None of those?
You said no. You said nothing.
Right. I'm thinking of my 30-1s. They got partial questions. You got a learning day. Hello. Assignment. Work. Let me see you work. I want to see you do some math. Wax on, wax off.
I didn't want to bleach my eyes.
Well, at least you have nice colored eyes. Okay. The steps are on this page, then we're going to move to the next one. So it says determine the equation of a quadratic function in vertex form. Whenever you have to determine the equation of any graph, you have to put it in vertex form. This is not an option. There's no other way. So even if I ask for it in standard form, if I give you a graph and I want an equation, you're going to have to put it into vertex form. So your step 1 is going to be replace P and Q with the coordinates of the vertex. Step 2 is replace X and Y with one of the coordinates of the point, and then solve for A, and then give the equation. So what the heck does that mean? So we're going to go over here. If it asks for you to determine an equation, a quadratic equation, it doesn't matter what quadratic equation it asks you to find, you will always put it into this form, vertex form. So you will always have y equals a x minus p squared plus q. That is the form you will always put it into. Even if I ask for an equation in standard form from a graph, you still have to put it into vertex form every single time. Okay? So step 1 is to get your P and Q. So step 1 is to get your vertex. What is the vertex of this graph? What's the vertex of this graph? 5 and -4. And I need to input them in as my P and my Q, correct? So I'm going to get y equals a, it's x, and then what? If P is 5, what am I going to put here? X minus 5. Right? It's always the opposite, correct? X minus 5. And then, what do I do? Minus 4, subtract 4. So that's step 1. Okay? I'm literally just taking the vertex, putting it back into the equation instead of taking it out of the equation. I'm just doing the reverse of what we just did. Step 2 is put in an x and y. Step 2. Put in a coordinate. Often one coordinate is bolded. I will go to that. If there isn't a bolded one, then I will pick something else. Well, there's 2 bolded ones. Okay, I'm going to pick this one. You could pick this one, it'll get you the same answer. But I'm going to pick this bolded one, which is at 2 and -1. I'm going to put that in for my x and my y. I just put them in the way they are. So I'm going to go -1 equals a, and then 2 minus 5 squared minus 4. So far, does it make sense? Get your P and Q, put them in. Get an X and Y, put it in. Okay? Step 3 is solve for A. And whenever it says solve for something, that means isolate it. I'll go like this so it doesn't look like solve for A. So I know I'm going to have to I can put these together here first. I'm going to get -1 equals A. 2 minus 5 is -3. -3 squared is what? +9. If in your calculator you go -3 and you don't put it in brackets and you square it, it's going to tell you it's -9, which is wrong. Okay? So if you want to type it into your calculator, you have to make sure you use brackets. So -3 squared is what this is, and it's 9. Minus 4. So how do I solve for A? Remember reverse bedmass when you solve. So what do I have to move? The 9 that's being multiplied, or the subtraction 4? The 4. I have to do reverse bedmass. So I have to do the additions and subtractions first, right? Whenever I'm solving. So I'm going to add 4. So I get 3 equals 9A. And I can write these out in A9 or 9A. It doesn't matter because they're multiplied. And then what do I do? Divide by 9. And A equals 1/3. Do I have an equation yet? I have just the A, and I have the other information, correct? So step 4 is write out the equation. So I need an equation. So what do? I go right back up to this one, this very first equation, and I just put the third in it. I don't fill in the x's and y's or it's not an equation. So I'm going to go y equals 1/3 x minus 5 squared minus 4. And then I type it into my calculator. So type that into your calculator. Make sure you put the brackets around the fraction. So the 1/3 needs to go in brackets. Go into your y equals and type in 1/3 x minus 5 squared minus 4. And then press graph. It should look like the graph. Now, You're comparing your graph. Can we pay attention? You're comparing your graph to a window that's at negative 10, 10, negative 10, 10. So you're assuming it looks the same, right? We don't want to assume it's the same. We want to make sure it's the same. So what I always do when I get an equation of a graph is I want to make sure it's the same as this one. We agree? So I'm going to change my window to match this window so that they should look, then they will look exactly the same. Not like, I think they are. Like, you know, if you're at a negative 10, 10 window and this is at a negative 3, 13 window, it's different. So I'm going to show you how to change your window. Okay? So we're going to type this in. You're going to tell me what it is again because I don't remember what it is. It's from yesterday. 3-1s. Okay. It was 1/3 x. What was it again? Squared. Okay, so we're going to go to window. Everyone go to your window. When we do zoom 6, our window's at negative 10, 10, negative 10, 10, right? It sets it back for us. But if I press graph right now, I could say, yeah, I think it's the same, but does it look exactly the same? No, it can't, because my window's different than the window that is on my graph, correct? So if I want to make sure they're the same, I change my window of my calculator to be that window, and then they will look exactly the same or not. Okay? So we're going to go to window. It says x minimum. What's the lowest x on this graph? Even more. Negative 3, right? Negative 2 is the last number, but negative 3 is my last actual x. Okay? So I'm going to go negative 3. Then I'm going to arrow down. What's my x maximum? Looks like 13. Then my x scales what it goes up by. What does each tick go up by? Looks like 1, right? So I leave my x scale at 1. What's my y minimum? Negative 5. What's my y maximum? Looks like 10. And what's it go up by? 1s. So now I press graph. Does it match it? Certainly looks like it, doesn't it? Now, obviously, this is horizontal and that's vertical, so they're going to be a little different, right? But if you look, okay, it crosses through here, it crosses through that tick, crosses through this tick, crosses through that tick, down here. 2, 3, 4, and a little bit. 1, 2, 3, 4. Yeah, it looks like it's crossing through it exactly the same, right? So it's just easier to compare if your window is actually the same window. Do you get what I'm saying? All right. All right. Try this one out. Try out number 2. All right. So we have to first get the vertex. So the vertex of this one is at 0 and 3. So I'm going to get y equals a x minus 0 squared plus 3. Do I technically need the x minus 0? No, I could just write x squared, right? It doesn't matter. Step 2 is using a coordinate. So I'm going to use 1, 1. So that's my x and my y. So I'm going to get 1 equals a bracket 1 minus 0 squared plus 3. 1 equals, and then 1 squared is just 1a plus 3. And I'm going to have to subtract my 3. Because step 2 is solve for, or step 3 is solve for a. So I get negative 2 equals a. And then step 4 is equation. So I'm going to go back and put it into here. So I'm going to get y equals negative 2 x minus 0 squared plus 3. So you could give me that as the answer, or you could have given me y equals negative 2x squared plus 3. Now, does this make sense? My a is negative. Does it make sense? My graph is what? Concave, down, so it makes sense. If your A is negative but your graph is up, question it. Or if your A is positive and your graph is down, question it, because you're wrong. Okay? We're not doing any homework on this. This is it for today.